All right, welcome back, mathematicians. Today we're going to look at solving equations. So last week we looked at modeling equations using our algebra tiles. Today we're going to look at solving equations. So what I've got here is I've divided my screen into two sections. On the left is where I'm going to model our equation using our algebra tiles. And then on the right side is where we're actually going to solve the equation, or we're going to write what's happening on this left side here. So I've got an equation here. It's the same. 2x plus 3 equals 9. 2x plus 3 equals 9. So the first thing I want to do is I'm going to model this equation using my algebra tiles. So when we model an equation, we just read it just like we read a book from left to right. So if I start reading this equation, well, I see first I have two x's, right? Those x's are positive. So I'm going to use my green bars to represent that 2x. After that 2x, I'm adding 3, right? I've got a positive 3 here. So whenever we have a positive constant or positive units, we use our yellow tiles. So I'm going to add 3 yellow tiles here. It is equal to, and then I have a positive 9 on the right side of my equal sign. So I'm going to take 9 yellow tiles. 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, so 2x plus 3 equals 9. 2x plus 3 equals 9. So here is an example of an equation that you saw in the 7th grade. I have a one variable, two-step equation. So when we're solving equations, our goal is to get one of these x's all by itself. So to do that, I need to cancel everything else out that's on the same side as my variable or the same side as my x. Okay, so what I want to do first is I want to get rid of this plus 3. I got to get rid of these yellow tiles right here. So to do that, remember, we create what we call zero pairs. So I'm going to take the opposite, right? So I know the opposite of a yellow tile is a red tile. So I'm going to take 3 red tiles and I'm going to place those red tiles next to a yellow tile. Whoops. 1, 2, 3. And because it's an equation, we need to keep everything balanced. So whatever I do to one side of my equation, I also have to do to the other. So if I added 3 red tiles here on the left side of my equal sign, I also need to add 3 red tiles on the right side of my equal sign. All right. Now to show what we did, we took 3 red tiles, which is the same as 3 negatives, right? Or minus 3. And we did it to the left side, which means we also had to do it to the right side. All right, so there we go. Now that I have these zero pairs, I can get rid of them. Because remember, if I have a 1 and a negative 1, it equals 0. It cancels out. 1 minus 1 is 0. 1 minus 1 is 0. So anytime I have a red paired up with a yellow, and I create those zero pairs, I can get rid of them. I can cancel them out. Okay? And to show what we did, so I'm left with 1, 2x. All right, this canceled out. Those 3 yellows canceled out. And then I'm left with 1, 2, 3, 4, 5, 6, right? 9 minus 3 equals 6. 2x equals 6. 2x equals 6. Okay, so that's our first step. So I know that 2x is equal to 6, but I want to know what one of these x's is equal to. So to do that, I'm going to divide. I'm going to group these yellow tiles to my green x tiles. So this x tile is going to get a yellow tile. This one is also going to get a yellow tile. This one gets a yellow tile. This one gets a yellow tile. This one gets a yellow tile, and this one gets a yellow tile. Okay, so all I did was I divided, right? I had 2, and I divided between my two x bars, right? So if I look here, I can see that 1x is equal to 1, 2, 3, right? 1x is equal to 1, 2, 3. So if I divide each side by 2, right? 2x divided by 2 leaves me with 1x is equal to 6 divided by 2, we know is 3. X equals 3, x equals 3.